I guess I'll cover both learning and advertising routes. I want to do it kind of by use cases, though, because at the end of the day, it's not just about seeing the code. It's like, what can you actually use it for? So, I mean, probably to give you guys a little bit of color on this, I work for Cisco. I've been there 4 or 5 years. My background before that was more in service providers, though, rather than in vendors. And so a lot of the use cases I'm coming from are ones very much from a service provider point of view. My involvement with OpenDaylight has probably been going for about 18 months now, and it started out with doing BGP testing. I'm just getting to the point where I'm putting code into BGP, which probably means the quality is going to start going that way. But I'm not really a coder. I'm an ex-coder, reformed coder, coming back to coding. So I want to give a quick overview of BGP and OpenDaylight, and then really go through these different use cases. So the first one's the BGP-LS PSEP use case, which will come with the first demo. Talking about demo gods, we're probably going to need some sacrifices soon, because I think I've got 3. And the odds of them all working are just vanishingly small, particularly I've got to change VPNs midway. So that's the first one. If it doesn't work here, it might work in a few minutes when Charles Eckler and I do the D-Cloud session over in the lab in the main room. Then IPv4 and v6, and the use case there is going to be for advertising v4 routes, so showing how you can inject routes into the routing system. Then go on to talk about FlowSpec, so that the latest address family to be added to OpenDaylight. So, really the history of OpenDaylight BGP was very much around BGP-LS and PSEP. So it started purely listening to routes advertised by a router, focusing on BGP-LS, because this was to get an IGP topology. But then v4 and v6 are pretty easy to do. And anyone who knows BGP, it's just a matter of TLVs and adding them. But then we added the ability to advertise routes. So that's through the AppRib. FlowSpec is then a way to advertise routes somewhat similar to OpenFlow, but using the BGP infrastructure. So you get a lot of benefit, I guess, from using the whole BGP route reflector infrastructure, the community strings and that sort of thing. And then BMP, the final thing I want to talk about, is something that we've added for Beryllium. So this was, it's basically for route analytics. So it's kind of a protocol. It's an ITF draft. It kind of piggybacks on BGP, and it's really for route analytics. And I think that's where there might be some interesting stuff going forward, because at the moment we've got BMP, but just to learn routes. What could be really interesting is we start to do stuff like integrating it, say, with TSDR, and actually doing stuff, I don't know if TSDR will be the right package, but being able to get the kind of historical stuff. So not just here's a snapshot of the analytics, but true analytics. So over time, these are the routes coming up and going down. Here are the events that happened. So overview. I'll start with what is the BGP plugin and how does it work. So pretty much everything I'm covering is going to fit into this framework pictorially. So you have OpenDaylight at the top right. Applications talking through different RESTconf APIs, typically talking to the topology, though in some cases you will want to talk directly to the RIBs. Then, as you see, BGP and PSEP being the 2 plugins we're using. With BGP, typically we talk to the route reflectors. So, I guess this is just a question of using each thing for what it's good at. The great thing with OpenDaylight is you get the fact that everything's Yang modeled, the fact that you can get topologies, and that's great. So instead of, if I wanted to communicate BGP, I don't now have to understand all the different TLVs and be able to decode them in my head or anything. I can do all that through REST. It's JSON, it's XML, it's all very friendly. That can then end up in a topology, which is great. But if you think about it, a topology is kind of the analog here for a fib. There is no fib in OpenDaylight. We're talking to routers. We are not a router. Now, it can function as a route reflector. Potentially, you could use it as a route server. But really, at this point, there's a pretty big feature gap to do that. Really, because if you know BGP at all, the complexity really all comes down to the policy. So it's all the policy engine that you have to filter routes and distribute routes and modify communities and all that sort of thing. That's not there in OpenDaylight today. Also, just in terms of performance, I guess BGP, you're looking for massive scale. Personally, I have some questions. Yeah, that's another point. Yeah, be interactive all the way through. It's much more fun. Yes. Yeah, and I'll show that as one of my demos if it works. And then, I guess my other question is whether something that's written in Java that's very Yang-based, how it's actually going to compare to something like a a route reflector that's written in C and has 20 years code in it. I guess that remains to be seen. But hey, CPU power lifts all ships. So the routes, I guess, the three basic classes of routes in OpenDaylight today, and this isn't to say we can't have more address families. So we could add VPN routes and that sort of thing. I think somebody was already looking at that. So say link state's where we started. Link state routes, you're getting them from your IGP, so from ISIS or OSPF. What you do is you distribute those into BGP link state, then the router will advertise those to OpenDaylight, which generates a topology. With V4 and V6, effectively that's internet routes. And we can learn them and we can advertise them. And then flow spec is something where we're actually pushing routes into the system, really as an open flow equivalent, and using BGP communities for that. The first thing, I guess, to get your head around is the structure of the RIB. So this is new, I think, with Lithium. Originally, we just had kind of a flat RIB, but the way routers are supposed to build RIBs is with this sort of three-layer structure, really, on the way in, where you have, and this is straight off the OpenDaylight wiki, so photograph away, but equally just go to the wiki. I would say, I think as we're all aware, the wikis leave a little bit to be desired in OpenDaylight in general. But I would say BGP is probably the best of them. I can't take much credit for that, though. So you have the adjacent ribbon. These are the routes you learn directly from your peer. And you have one of those for each of your peers. Then the effective ribbon writer will generate the effective ribbon. So that's basically the post-policy rib. But as I said, there's very little policy today in OpenDaylight. So there won't be an awful lot stripped out there. It's things like blocking your own AS, I guess, would sit in there. And then we have the lock rib writer, and that's generating the lock rib, which is the main rib for the system. So that's across all the peers, and that's where you get the BGP best path algorithm that runs. So if any of you know much BGP, there's the, you know how it is, none of us know this in our heads, so we either have it printed off and written on pieces of paper by our desks, or we just Google it when we want it. And it's basically, these are the rules, wait comes first, and then local pref, and so on and so on and so on. So there'll only be one instance of that. So hold that thought for when we get to BMP. Then we also have a rib out for each peer. I guess one thing to say about this is probably this again, is where there could be some interest. We've done the clustering, and clustering's there in Lithium, and it's working. The issue is you've got to do clustering for each protocol, really, because the question is, how do we handle it southbound from OpenDaylight with BGP? So we could, for example, implement BGP graceful restart and have just one peer from a router to ODL, and then flip them over and then be replicating state. But it might make more sense to have two separate BGP connections to different nodes in the cluster, and then only to cluster the topology information, not the RIBs. But we haven't reached a decision on that. So that's, again, something that we need to think about as we go forward. So topology, so just sort of covering these four areas. And the thing about OpenDaylight, to me, is one of the most powerful things is topologies, ultimately. You can see it basically in terms of the syntactic conversion, as I mentioned earlier, going from BGP routes that are all TLVs and very binary to going to JSON or XML. But with topology, you get that semantic conversion that you're now saying, well, I'm not just looking at a set of routes, so I can look at my link state routes. That's one thing, but actually the topology is much more valuable, because in the topology, it is just a list of nodes and a list of links where the links interconnect the nodes. But what's most powerful about it is that we have one topology model that we use, the IETF topology model, that then gets augmented into the different topologies. So to me, that's real power, where you can write one piece of code that draws a topology, and the code doesn't really need to care whether it's drawing, like a BGP-LS topology or an OpenFlow topology or whatever else. As an example of that, the first demo I'm going to show, the code we have there that draws a BGP-LS topology, about a year ago, I think it was for an ITF, I hacked that to do a home net topology instead. And that was a trivial piece of work, because the topology model is still the same. The source might be different, but it's the same topology model. So configuring BGP, and I guess I threw this in because of what's going forward as well. So today there are two ways to do it. So either you have the config files that sit in etc. OpenDaylight carafe, but then once you're running, end up in etc. OpenDaylight current, and the BGP files 41 BGP example. So you can edit that. But what I tend to do actually more often is use resconf. The only issue there, of course, is the massive length of the URL, and getting even longer with Lithium given that in Beryllium we're going to drop the inventory, so this is showing it as of Lithium with using network topology rather than inventory. So the first thing you need to do is set up the RIB itself. The gotcha you've got there is that if you want to listen on port 179, which is the default port for BGP, and the only port your router's ever going to talk on, then you need to run as root. Alternatively, don't worry about it, don't run as root, and rely on the fact that you'll always connect outbound to the router, and that'll work just fine. Then configure the RIB itself. There's not a huge amount to do there, but the key thing then, of course, is adding all the peers, and that includes the application RIB, and I'll come on to the application RIB and how it's kind of like a peer. It's a slightly unusual model. What we're going to be doing going forward, I don't know if any of you were in Anis's session yesterday on OpenConfig. At the IETF hackathon a couple of weekends ago, we implemented the OpenConfig model for OpenDaylight. So that means that you can configure the OpenDaylight BGP speaker using the OpenConfig BGP model rather than using our own BGP models. Now I don't know when we'll get that into the shipping product, but you'd hope that Beryllium, whatever, will have that in there. And of course, the other thing is if you have southbound routers that talk OpenConfig and have netconf yang, then of course you can use OpenDaylight to configure those routers themselves. In fact, you could configure them today with any Yang model, but to be honest, I'm old school. I'm CLI. So the BGPLS topology. So as I mentioned, the source is either OSPF or ISIS. We distribute that into BGPLS. So we learn that RIB from the BGPLS speakers. So as I've shown here, typically it would be a route reflector. I mean, not really reflecting the BGPLS routes because the routes are coming straight from the IGP. Now, one of the cute things here is even if your network of routers doesn't support BGPLS, if you get hold of a virtual router that does support it, you can put your virtual router in that topology. So imagine you have, and I'm going to speak Cisco terms, but translate it to your other vendors. If you've got a network of iOS Classic, easy enough to take a virtual XR node, run BGPLS on it, put it in the same IGP, and then you can get that IGP data. And this supports all the MPLS traffic engineering extensions as well, for things like bandwidth allocation. We're adding support for segment routing. I think that's in the Beryllium code now. Yep. There's a little bit of extra work I think we're doing for SREPE, but I guess we'll get that pretty soon. Where was I? The only thing about this is that you only really get the topology for one area. It's the area that BGPLS speaker's in. And the funny thing is, if you think back to when PSEP was originally conceived, the whole PC architecture, the goal of that architecture was to enable inter-domain traffic engineering, to get you round the problem that an individual node running CSPF only sees its own domain. So what happens when it wants to talk to another domain? So what you can do is have multiple BGPLS speakers talking to ODL, either directly or using route reflection. The challenge you'll get is the routes look different because the routes are effectively tagged with who originated the route. So if you have, say, I should have had a picture of this, but if you have, say, as in the other picture with the multiple, if you think about it in terms of, say, these domains, if these guys were the BGPLS speakers and they're all talking to ODL, and if they were in a backbone area, say, and these were areas 1, 2, and 3 in OSPF terminology, you'd basically get 3 copies of the backbone area with the 3 different originators. You then get a copy of each of these areas, but the originator tagging would be different because it came from a different area. So I think one of the tasks we do need to do is to generate like a multi-area and a multi-domain topology model in OpenDaylight. Not so much the model, but the implementation. I think we need to get that in there.
Can you comment if that would extend to topologies of other southbound protocols like OpenFlow domain or working with the BGP domain?
That's a good question. I'm probably not the right person to ask about OpenFlow, but I guess you could take the same approach if you have multiple domains. I mean, OpenFlow today, the topology gets learned purely because the OpenFlow device connects back to the controller.
Yeah. Either it's a database or it's learned, right?
Yeah.
So you have topology.
I think what you'd probably get today is if you had multiple OpenFlow domains and if they're all configured to talk to the same controller, you probably would see effectively one topology of nodes and links. But if you were to then try and graph that, you'd find that those were disjoint sets of nodes and links. You'd see them as separate clouds, I'm guessing. Try it out. So what happens then with PSEP? So PSEP's kind of like OpenFlow in that sense, that the routers connect back to the controller. So with BGP, we went in and we configured the routers in the controller. For PSEP, they connect to the controller. And initially, what you see with PSEP is just a list of the routers that talk PSEP. But then as you add LSPs, you see effectively the list of LSPs that you're the head end for. And that topology, again, that's the URL for it. This might be time for a demo. Other things to say on PSEP, there are two different models you can run it in. One is a model where the LSPs are pretty much owned by the controller, initiated by the controller pushes them down onto the devices. So again, I'm not an expert on other people's CLIs, but if you look at XR, you basically say, well, here's a range of tunnel IDs I want to use for my dynamic tunnels. They're not in the config, but when you add those LSPs, those tunnels appear in your operational state on the router. And you contrast that to the other mode, where you go in and configure your LSP on the router, but on the router you say, I want to delegate path selection to the controller. So again, that's XR CLI, and I'm sure somebody will know the Alcatel, Juniper, and others. And so effectively, we're just saying, for this LSP, hand it off to PSEP, and somewhere else in the config file, I've configured my PCE for PSEP, and I've said I want to delegate it. And at that point, to set that path in ODL, you just do the update LSP. You don't go in and do the add LSP or the remove LSP, because that's being controlled by the router. You just update it. And so, in fact, back to topologies, the PSEP topology I mentioned, it's just a list of the routers. There's no links. It's just a list of nodes. For each node, you then get the list of LSPs it's the head end for. But the PSEP topology is augmented from the generic topology with these three RPCs. So if you look at the URL, you can see that add LSP RPC is actually rooted in the PSEP topology. So demo, here's the fun part. We should take bets, right? It's not like I'd buy everyone a beer if it goes wrong. Actually, definitely not. First thing I should probably do is shut down anything that people might start sending me messages. OK, so I think I'm on the VPN already. Yep. And I think I'm on the right one. That's good. All I can do is remember which browser. Oh, it's this browser. Excellent. So here we have a topology. This is running in dcloud. So this is basically what we've got is virtual machines in a data center somewhere. We've got an instance of Viral, which is itself a virtual machine. Within Viral, there are 8 different virtual XR nodes. We then have another VM that's running OpenDaylight. So I can now add some LSPs. So I do create new LSP, pick a source node, pick one I can remember the IP address of. So that's, I can't remember how to do this. Pick a destination, Seattle. Why not Seattle? It's always a nice place, apart from the weather. So ODL's running on a separate VM within dcloud, but not within the Viral VM. You can run it that way if you want. It's always one of those things, you know, the great thing with virtualization is that you can run everything without real hardware. The worst thing about virtualization is you can do so many layers of it, you get lost as to what's where, and performance starts to suck when you have VMs and VMs and VMs. So we'll just pick, you know, we can just pick any of these paths, and you can see as we go through them, it's showing them. That looks pretty horrible, doesn't it? Let's take that one, because we think that's OK. And we give it a name. There's only 2 names I ever use. There you go, it's created. So let's see if I can find, because you don't believe me, it's in there, do you? So let's find a terminal. Oh, we're still there. Yep, complete, straight ODL. Oh, the UI, that's, it was some stuff that some of our developers wrote just running in Tomcat. I'm not sure if that stuff's open source. If it's not, it probably should be. We have a slightly different UI that's running on the booth that's part of the Cisco Open SDN controller. But given that they're different, we should probably give this one away. I don't set policy, fortunately. So you can see foo, I've created that. To prove that it really was me that created it, I suppose I could delete it. And then with a bit of luck, yeah, the tunnel's gone. And you can also do them, you know, click hop by hop, sort of clicking on the nodes, which is quite cute. This is stateful 07. Which stateful draft are we using for PSEP? So we're using stateful 07. I mean, ODL implements 07 and 02. I think life's got a lot easier once we've got to lithium, and from a Cisco perspective, once we got to XR53. It used to be you're always messing around, making sure you had the matching versions of the stateful PSEP, and making sure you had the matching link state attributes. But now that the latest ODLs and latest XRs seem to agree, it's taken all of that pain away. So at stateful 07 and for BGPLS, we're now using the IANA assigned link state attribute. So all of this, this app is just sitting on top of BGPLS and PSEP. So the BGPLS part of it, we did quite a while ago now. And then one of the guys who runs the dcloud infrastructure, in fact, said, oh, hey, I can add PSEP to this. Sorry, to configure BGP? No, that's the great thing with RESTconf. It's all live and on the fly. Of course, you've got to watch out for the fact that as of Lithium, you have this thing that if you use post, then you have to think about if the data's already there, you can't overwrite it. So generally use puts and deletes rather than posts. I mean, I can show that if you want at some point, just adding it in. OK, so that was the first demo. I should probably cut it short, or you'll never get away. So let's come off that VPN. And while we're here, I'll join the other VPN and hope that all works. Yeah, my other demos might be a bit cut short if I can't get on. Because what that was is we have a separate kind of VPN connection into the dcloud infrastructure. And the reason for that is because obviously within dcloud, we reuse the same IP addresses again and again. So by going into that specific VPN, I had access to the routers directly rather than via the server. So I should now be on the proper VPN, so I can show the other demos. That's good. So let's get back to the PowerPoint. So the v4 topology. So this really is just generic BGP. I mean, v6 as well, of course. But in the v4 case, this really is the old internet that we all know and love. And you can even just pull an internet route feed into ODL. That didn't work so well back in hydrogen days, but performance-wise, it's OK now. So in this case, it's the standard v4 unicast routes, or v6 if you use v6. In this case, yes, connect to the route reflector, and that will bring in all the routes. So in this case, connecting to an RR, you'll see the routes from these different BGP peers, unless next hop cells happened, et cetera. The topology in this case is kind of funny because it's just a list of all the BGP next hop routers, and for each one, a list of all the prefixes they originate. Yes? Yep. No open flow. Yeah, there's real SDN. There isn't open flow. Yeah. Yeah. Yes. Typically the route reflector. I mean, you can talk to any router, but as I say, it's easiest to talk to a route reflector because then he can take care of the policy, and you just have to learn the routes and turn them into YANG, turn them into topologies. So, in fact, when you get to flow spec, you'll see there's a lot of similarity with OpenFlow, but not so much with these address families. One thing I'd like to see us do, sorry. Right, so there's two ways you can look at it. One is if you're just learning routes, then it's just letting you see all the routes in the network. Now, I'm not sure how much value that's going to have now we have BMP, because that gives you more flexibility. But you could just look at the routes and say you can generate the topology, but I don't see the topology itself as that interesting. I think what I'd like to see us do is add some more topologies. So I've been having some thoughts about that in terms of, for example, could we have a topology that was a topology of autonomous systems rather than a topology of BGP routers? Things like that. Could we do a generic IP topology that had effectively all the routers you know about and all the prefixes each router initiates, et cetera, in sort of a more flexible way? And that might then add some value. I think that the question is always, it's easy to think, well, I could make a topology that looks like this. The question is, what's the use case for that topology? And I'm not sure at this point. Yeah. Right, which again is where BMP is really handy because you can see your neighbor's ribs effectively, not just your own. Yeah.
What is the protocol between the front and the BGP?
BGP, yeah. This is all just standard BGP.
So you have to configure the route reflector for OpenDaylight to be up here.
Yeah, so typically what you do, particularly with a lot of iBGP originated routes, is you configure the route reflector to consider OpenDaylight to be a route reflector client, because that way any route initiated within that AS will get to OpenDaylight. So the same, I mean, the V4, I guess, is the first use case for advertising routes. So this is just saying we can actually push routes into the routing system. Now, this happens in a kind of strange way. And the reason for this is because in OpenDaylight, the BGP rib is operational data, not config data. So you can't modify that because it's upper state. So instead, we create the second rib, the app rib. So effectively, what happens is the app rib is an iBGP peer of the main BGP rib. So this is where it starts to hurt your head. So basically, you're doing a config against the app rib. From the app rib, the routes then get into the BGP rib. But the problem is all the standard BGP rules apply as to what routes get into the BGP rib, and more importantly, in terms of what routes get out of that rib. So the problem with having made it an iBGP peer is that now we can't really do iBGP peering with the guys southbound because we won't reflect the routes. Because iBGP by default, you don't reflect. The problem is if you do eBGP, you can't lie about your next hop. So I think that's the next thing we've got to do is fix that so that we can lie about our next hops. Because the two main use cases I can see for advertising routes involve basically faking your next hop. Yeah.
The major use case here is BGP and RGC used by Microsoft and Facebook. This is where you use unicast routes. You
Yeah.
need to be able to advertise routes to override third-party next hop.
But those guys, I think, run eBGP, don't they? So we should be okay. Yeah.
BGP, but you need to
Yeah. 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 So there's one at the back. I don't. Yeah. I don't have it off the top of my head. I could come back to it. We did do some testing recently on that, basically to prove to ourselves that we could handle full internet routes fast enough. What you find is you get better performance still if you use BMP, because BMP you don't have to do. Remember back to the three-stage thing I showed you with the app rib, the effective rib, the lock rib? You don't have to go through all those stages and then off to the topology. So I guess that's the sort of thing we need to think about is, are there bits we could shut down if we wanted to get really high performance? I mean, hopefully in a multi-threaded environment, sufficiently parallelized in terms of CPU cores, we'll be okay. But I think we need more work on that to verify it. And I was thinking that even with the stuff where you have lots of different neighbors, to an extent, in a clustered environment, could you even get to a world where the different neighbors are on different nodes in the cluster? But then are we going to have a major sort of locking contention problem on the lock rib? I guess we'll suck it and see and find out what happens. Well, I'm sure we can put it up there. I mean, all this data always comes with caveats, right? Because it's going to be, this was testing it with whether it's ExaBGP or iOS XR, the spec for the thing, what type of routes we fed in. Because obviously, if you feed in real internet routes with all the different community stuff and long AS paths and whatever, that's going to be more work than feeding in a synthetic set of routes that doesn't have that stuff. What was I going to say? So yeah, eBGP for now. So I'll demo that just for giggles. We're 1 for 1 so far. What are the odds? Right, this guy will have died because he's on the wrong VPN. So let's bring a new one. Right. So this guy should only have a local BGP route from a real, these are a couple of real ASR 9Ks over in building 16. And I'm trying to ping the server where ODL's running, and it's not really working. So let's go to ODL. I don't want the, which one I want? On a poster route. I think I had all this running already. Check I'm talking to the right controller. I want to put one, actually. That's better. I better put in that guy. 1.0. Is it just me, or is that %2F stuff really, really annoying? There are one or two cases where they cleverly made the key like a composite key that had an IP address and a prefix. Now, that was cunning. But where it's part of, yeah, really annoying. I kind of wish we hadn't numbered our Ethernet interfaces with slashes in as well. No, it's 1.0, isn't it? /24. Oh, this is so going to go wrong. It might not have done. Yeah, see, it's gone wrong. OK, so I'm still, one demo worked. So this is where you start getting to the fun of actually checking what I did underneath. Like, is BGP even running? I can't even remember my BGP. This is worrying. It is neighbor, isn't it? I just isn't. Ah, did I kill the controller? That's entirely possible. Or kill the BGP. Well, I kind of killed it because it's running. Maybe I killed the BGP in it. Oh well, we'll come back to that. I'll do it at the end if I get time. I'm sure I can fix it. So 1 out of 2 so far. Flow spec. So the thing about flow spec is it's very much like OpenFlow. So I guess that's the first thing to think of. Think of it as OpenFlow, but using BGP to distribute the match actions. I guess the one challenge with it is going to be it was designed for IP, so there's no MAC address matching. Well, not that I'm aware of, so maybe we need to add that. You're looking like you want to add it.
There's some line work for EVPN.
Ah, of course, yeah. I'm trying to forget EVPN. It's one of those things that's, I don't know anyone here. I used to be the Layer 2 VPN working group chair in the ITF, and I'm really trying to put that stuff behind me. It's like ATM. I just don't want to remember it anymore. Sorry, Ali. So then, and then the actions you basically define using BGP communities, and the RFC basically gives you a set of default actions you need to support. But you can just invent new ones. Sort of the sky's the limit in terms of your imagination. And then you'd use that like the app rib, only in a way that works, not like the way I just showed you where I took my BGP session down, which I will fix. So BMP, actually I have a sudden thought. Maybe I was on the wrong controller. So BMP, basically it's an ITF draft. What it is, if you think back to what I had at the beginning, that picture with the rib structure, what it's effectively letting you do is get at your peers' adjacent ribbon and effective ribbon, not just the lock rib. So what that means is if I'm on the BMP speaker, which is also talking BGP to these guys, as well as seeing what I know about my own best routes, I can see the routes these guys are sending me. And I can see them either before or after I've dropped stuff based on policy. So as I say, it's kind of taking off now as a really analytics protocol. There are some cute tricks you can do with it as well, because you can break some of the BGP rules if you've got routes before you've picked the best one. You can choose your own algorithm for picking the best route, for example. As I say, I think what I'd like to see us do is more kind of historic stuff, so not just snapshots, but can we actually store this stuff in the data store and track it all, and then actually be following, these routes came up and down at these rates, whatever. I mean, there are other packages that do that. So there's OpenBMP. There's a guy at Cisco who's now in our team who I think he wrote it in his spare time when he's working as an SE. And that's written in C. It's going to be hard to beat it for performance. But the thing is, once you're in OpenDaylight, I guess that's it. We can leverage all the other stuff. Well, that's the plan anyway. So let's see if that one's going to work. I'm feeling really bad. One demo failed already. This is it. This is the tiebreaker. Or I could be buying everyone beer. Oh, there you go. So let's pull out full screen. So this code's now in Beryllium. So if you look at the BGP release plan for Beryllium, this is in there, and the code's already been written. So you can see there's actually a bug in the middle of the screen. That's always good to see. That post-policy rib's looking very, very empty. And it shouldn't be, should it? So these are the routes we've learned, the pre-policy stuff. I should probably show you on the router itself so you can see what's actually going on. So on this router, and I'll step up the size a bit. So if you look at this neighbor, gotta remember his address. I think it's this guy. Yeah, so we've got a BGP session up to this guy. But what's interesting, if you look in the config, is we have BMP running on port 12345, because I'm very creative. But if you look at BGP, what you'll see is for that one neighbor, I've basically fired it at BMP. So everything I learned from him, I'm passing on to the BMP server. And as I said, I'm going to do that before I've made my own best path selection, which is why you can now see for that guy. So I'll say this is a Mac. I can't even get out of this. Oi, stop, let me out. Yeah, so you can see the router ID there at the top is the guy that I was just showing you the SSH to. The next thing's the peer where we'd enable BMP. And then you see for that peer, we have the pre-policy rib and the post-policy rib. The pre-policy rib, you can see, I mean, most of these routes are getting dropped because they have our own AS on them. And that's the first thing you do, obviously, is get rid of anything that appears to come from yourself. But as I say, the bug here seems to be that if we come down, I would have expected this network and this network to have ended up in my post-policy rib, which they didn't. But hey. And also, yeah, there's some statistics or whatever on the session. So as I say, I think we're probably going to see more of that in future, people using it as an analytics tool, also using it where they want to do funky stuff and override best path selection.
Sorry, can I just interrupt there and ask about the best path selection? Are you saying that by having visibility into the adjacent ribs,
Mm-hmm.
that I'm just trying to join the dots between how having that visibility allows you to override the best path selection in a way that you couldn't without it?
So basically, yeah, if I've learned a set of routes from different people, and I've learned those original routes, and so say there's a route that's been disaggregated, but I want to pick the one with a shorter AS path. If I've got all those routes and I can feed them in through BMP, then within ODL I can write code that will then re-advertise routes and that sort of thing. So it's more that you can, it's not, effectively, again, it's the classic sort of open loop thing we do. So if you think about BGPLS and PSEP, you're learning with BGPLS and you're programming with PSEP. In this case, you'd be learning with BMP, but you'd be programming with BGP. So you'd be firing routes in, again, with fake next hops and that sort of thing to override the stuff you wanted to get rid of.
That would be based on static.
Maybe based on whatever you wanted to, I guess, because it's code. So there might be some clever idea you've got. You don't believe the meds the other guy sends you and you want to turn them upside down or something. I mean, it could be anything. I think it's in the long tradition of BGP where the number one thing we do is give people enough rope to hang themselves. Use that sort of thing with just unbelievable caution. No. That could be kind of fun. So I don't know, am I going to dare an attempt at the other one? Because it so should have worked. Maybe I'll see why my BGP session's down. Ask more questions while I'm futzing around as well, because I think we still do have like 10 minutes. Okay, so we have. I thought that guy was already up and running. Wrong one. I know what it is. I need to configure BGP on that guy. I hadn't actually done it. So that was more like a deliberate error. So back to what I was saying about configuring it with RESTconf. So basically, I'll fire in the rib. That looks good. I'll add a BGP peer. You can see, in this case, that peer is an external peer in that AS. So that should be in. We'll look for we'll add the app peer. So you have to actually configure the app peer. So I'll fire that in. Let's go back to that ping then. So, yeah, sure. The app rib, I'll come back to that slide. So basically, what it is the app rib is the means by which you inject routes into the routing system effectively. So if you come back to that slide I showed on the app rib, and I'll maybe try and talk through it a bit better. So what you're doing with the app rib is you're using RESTconf to configure routes in this app rib. So normally the rib, it's operational data, not config data. So you can only get, you can't put it in. So we put a route in there and it's config. What happens then is that route goes into the main BGP rib. The rules by which it does that are the same as the iBGP rules. And so that's kind of a little bit funky. And that might be one nice thing if we implement the open config model properly is hopefully we can implement it to the point where we're not doing that anymore. Because if you think about it, anytime you're on a CLI on a router, you just say, you know, the classic, what I'm doing here is equivalent to, say, putting a network statement in under BGP, but I'm doing it in this strange other app rib to push the thing in there, which I think maybe part of the issue here is it's the sort of software developers versus network geeks. And maybe I should have taken a look at what they were doing with that rib before it arrived. But I think all of us who have more of a networking background probably need to be keeping a closer eye on what's happening in terms of features, just to verify they make sense from a network point of view. And I think sometimes, with ODL, to me also, there's that thing that things can be a little counterintuitive when so for example, adding a BGP peer. I mean, it is ultimately the same as on a router. You add the peer, but whether the session comes up as a separate thing, so the config statement will work immediately, but all that says is you've added it to the data store. If you configured it with the wrong IP address, it's not going to come up. So maybe we're going to need to do stuff like have synchronous RPCs that actually connect to something and don't come back until it's connected, and that sort of thing. Which I think with OpenFlow we have that. You can either access the config directly, or there are some RPCs you can use to put flows in that actually verify it goes in, I think. But I'm not the OpenFlow expert. Sorry, the app rib, yes. Yeah, it'll still be there, which is a pain in the neck sometimes when you're testing and you want to get rid of stuff. No, at the moment it's just one, and it has all the multiple address families. I guess you could ultimately do something like that, but then you have to define, I guess, which app ribs connected to which real ribs, which should probably get a bit confusing. Sorry, VRF? Not yet, but I think there are people working on it. Okay, so let's come back to that. And I can actually show you the put I was going to use. So then, put a route in. So if I show you this, and this is the one I've got to change because I don't want that route, I want this one. And so basically you can see if you've got very sharp eyes, you can see, yeah, you can see the config at the left. I tend to do this thing in Postman where I script out all the fluff at the front of the URL because otherwise it just gets crazy. But if you see config, it means I'm hitting something in config. So then if I put that in, let's send that. So it seems to have taken it. Whether it made it to the router is another question. Yes, it did. So if you look at the route, you can now see that the upper one of those two routes, the bottoms, come in from ODL, and that's from the app rib. So as I say, I think the big thing on the app rib we're going to have to fix is the problem of it being iBGP, and the fact that means if you've got an iBGP peer, the routes never get there. So maybe we need to create some kind of pseudo peer type that's kind of like a route reflected client, but where we don't add on an originator ID and a cluster ID. That might be the right way to do it. It's the fact that you can't, that the rib data is all operational data, not config data. You'd think so, yeah. Unfortunately, I'm not. Yeah. That's way down in the internals and stuff I don't really get. So I think it's down to sort of things like data brokers that I really don't understand as to how you get stuff in and out. Yeah, I think so. Yeah, because I mean there are other sections where you can have a mixture, I guess, of config and operational. At one level, it would seem to make sense. You could have config and you just reflect the config into operational. Maybe that's something we can look at again as to whether we could do that. But to me, yeah, the main constraint on using it is that faking at the moment you can't fake the next hops, which seems to me to be the thing you're going to want to do. So I hope that covers everything you wanted to hear. Any more questions, Alfina?
So it's a minor question, but going back to the Brooklyn
Mhm.
collection, you have the address in the URL and also inside. What happens if they don't match?
Then it complains. And the reason I've got them there is because I'm having to use puts because of Lithium not supporting multiple posts. It's a pain. I don't know why we changed that. Probably to follow the REST comp spec better or something. Yeah. Cool. Well, thanks, guys. And if you have any other questions, just feel free to just ping me directly or ask on the ODL BGP list, and I'll see what I can do.